Hi guys! So here is the video on the remaining slides in the Unit 4 notes. All right, so we did up to 10 the last time. We're going to start with slide 11. We start talking about proving quadrilaterals are parallelograms. Remember, they need to use one of these properties in order to prove it's a parallelogram. You either have to have opposite sides being equal and congruent. It has pairs of opposite angles that are congruent. Consecutive angles are supplementary. If the diagonals bisect each other, then you know it's a parallelogram. And if the diagonals form two congruent triangles, that again would give you parallelograms. So let's look at the first slide here where you had to answer. This is slide 12. On the left, you had to determine if the three figures below are parallelograms. So if we look at this one, is this first one a parallelogram? And you can always click insert and type in your answer, whether it is a parallelogram or not. So insert text box, put it right in there. But for this one, notice opposite sides are parallel. So if we look at those properties of a parallelogram again, opposite sides are parallel. So yes, that is one of the options to prove that they are parallel. So this first one, yes, it's a parallelogram. The next one, opposite sides are congruent. Again, that is a yes. And the last one, notice we have one pair of parallel sides and one sides that are congruent. In order to prove that it is parallel, it has to be all right. And again, remember from our document 18.4 homework assignment that you guys did, we had at the top conditions for parallelograms. And one of the ones that was listed there says both pairs of opposite sides are parallel. One pair of opposite sides are parallel and congruent. So in this case, it's not the same ones that are parallel and congruent. It's different ones. These are parallel, and then the ones on the other side are congruent. You have to have one pair of sides that is both parallel and congruent. So that does not fit that one. Both pairs of opposite sides are congruent. Nope, that doesn't show it here. Both pairs of opposite angles, doesn't talk anything about angles. And finally, diagonals bisect each other, nothing about that here. So this last one is a nopers. That is not a parallelogram. All right. So we're trying to prove here that a figure is a parallelogram. And again, we are given some information. We are given that DB bisects AC. So that tells me this is congruent to this segment. Angle 1 is congruent to angle 2. Notice those are my first two reasons. I said that it bisected it. The second one, that it was given. My third statement here, AE is congruent to EC. That is definition of bisecting. We say it bisects it, it splits it into two equal parts. All right, and then my next step, angle DEA is congruent to angle CEB. So that is these two. They are congruent because they are vertical angles. So that one congruent to that one. All right. Next, I can say the triangles. DEA is congruent to triangle BEC. If you notice, we have angle, side, angle. Two pairs of congruent angles. and the side in between. So the reason they are corresponding, or the reason they're congruent, angle, side, angle. All right, then we can say DE equals EB. If we've proven that the triangles are congruent, we can then say all the little corresponding parts are congruent. And DE and BE are corresponding sides. So again, that's CP, CTC. Corresponding parts of congruent triangles are congruent. Why can I now say that AC bisects DB? Well, we just said that these two are congruent, DE and EB. Since those are congruent, that means that segment is bisected. So that again is the definition of bisecting. And finally, we can say that ABCD is a parallelogram because the diagonals, which is AC and DB, bisected each other. All right, so that was slide 12. Again, feel free to pause this if you need to. All right, let's look at another one here. Slide 19 starts talking about, slide 13, lesson 19, starts talking about some special parallelograms. So rhombuses, rectangles, and again the square, which is kind of the child of both of those, has to fit both of those requirements. So we've got 14 here. We are given that ABCD is a rectangle, and we have to prove that angle EDC is congruent to angle ECD. All right, well, let's start. We say angle ABCD is a rectangle. Remember, we always start off with our given information. So the first answer there, our reason for saying there's a rectangle is it is given. All right, so we know it's a rectangle. Why can we take that step to number 2 to say that it has 2 right angles? We could do that because that is the definition of a rectangle. And again, notice with our proofs how we build off of the step above. We say it's a rectangle and then kind of use the fact that it's a rectangle, part of the definition, to prove step 2. So we've proved that ADC and BCD are right angles. Why can we now say those two angles are congruent? Because all right angles are congruent. They all equal 90 degrees. So we've got the 2 congruent angles here, ADC and BCD. Those are congruent. Diagonals bisect the angle ADC and BCD. Why can we say they're going to bisect it? Because that's one of the properties of a rectangle. Property of a rectangle. Property of the diagonals of a rectangle. And then I can use that fact, again, that we just said that the diagonals are going to bisect it, to officially state that EDC is 1/2 of ADC. So EDC is half of it. We can also say ECD is also going to be half of the big right angle. Again, because that's the property of a diagonal in a rectangle, that it's going to be bisected. And notice here, remember up above, I said these angles are equal to each other. And now I'm saying these two angles are equal to ADC and BCD. So my first statement, EDC equals half of ADC. Since I said they're equal, I can now replace that. So I can put BCD in there instead of ADC. That's the substitution property. If I said they're equal, I can substitute it anywhere in there. So that's, oops, come on, substitution. And finally, notice I said ECD is half of BCD. And we just stated that EDC is also half of BCD. Notice they're both equal to half of BCD. Since they are both equal to the same thing, we can then set them equal to each other. And that's our friend, the transitive property, setting them equal to each other. All right. And finally, we're going to look at slide 15, which deals with some rhombus. Let's take a moment, look back at rhombuses here on slide 13. Remember, they are parallelograms. All four sides are equal. Opposite angles are congruent, just like a parallelogram. Diagonals bisect each other, just like a parallelogram. Diagonals are perpendicular. So keep that in mind. That's a new one. Diagonals are perpendicular. See how they are perpendicular to each other. Diagonals bisect the vertices. So they bisect it, split it into two congruent angles. The diagonals are not congruent. In rectangles they are, but not in a rhombus. And of course, consecutive angles, supplementary. So if we look at that, if we're trying to find x, y, remember that a rhombus does have four congruent sides. So since side VW is 6m plus 12 minus 12, and WX is 4m plus 4, I can set them equal to each other. Because rhombuses have four congruent sides. And I can subtract 4m from both sides. Add 12 to both sides. And I find that m equals 8. Be careful. Remember, the question is asking, though, what is xy? Not asking what m is. What is xy? Well, xy has to be the same as VW, the same as WX. So you need to plug 8 back into either one of those equations. You should get the same answer. 6 times 8 minus 12. 6 times 8 is 48 minus 12. 36, I believe, if I did that correctly in my head. I can check that. I can put it into the next one here. 4 times 8 plus 4, just to check and make sure I get the same answer. 4 times 8 is 32, plus 4, 36. So xy must also be 36. All right, so we need to find the measure of y v w. So y v w. One thing to note, notice it has an n in here to help find some of these angles. This one has an n in here as well. But remember, we talked about the diagonals being perpendicular bisectors of each other. So this 3n squared minus 0.75, that has to equal 90. So 3n squared equals, if I add 0.75 to both sides, get 90.75. I use my handy dandy calculator because I don't trust my brain. 90.75 divided by 3 tells me n squared is 30.25. And remember, to finish solving this, I need to take the square root of both sides. I end up with n equaling 5.5. So keep in mind that n does equal 5.5. We are trying to find the measure of YVW. So I can look here, if I plug this in, I put 5.5 in there, 9 times 5.5 plus 4. So 9 times 5.5 is 49.5 plus 4 is 53.5. And that is just part of the angle. But remember, one of the things we said is that the angles end up being bisected. So if this little red part here is 53.5, that means this has to be 53.5 as well. And if they're both 53.5, then the big angle, YVW, is 53.5 times 2, or 107. If we want to know VYX, that is a consecutive angle to the one we just found, YVW. VYX is the next consecutive one. It means they have to be supplementary or add together to be 180. So 180 minus 107 is 73. And if we want to find the last angle, XYZ, remember we said the whole angle here is 73. The diagonal is going to bisect it. So XYZ is going to be 73 divided by 2, or 36.5. All right. I think that was the last slide in there. Hopefully that helps, and good luck on the exam.